Welcome back, Physics 30. This booklet you have, it's kind of in between the Part 4 and Part 5 of the acceleration booklets. It deals with average and instantaneous acceleration. It's very similar to average and instantaneous velocity when we're looking at the position time graphs, but now we're looking one step further at velocity time graphs. So if a velocity time graph is a parabolic shape, curved shape like this, then the object does not have a constant acceleration. However, the average acceleration of the object over time can be determined by, as we have been before, change in velocity over change in time, or v2 minus v1 over t2 minus t1. So if we were doing between t1 and t2 here, it's just a straight line joining those points, and your t1 v1, your t2 v2 point, and figuring out the slope of the line there. So as you can see, we're calculating the average acceleration. You're really determining the slope of the straight line segment over the elapsed time. So if we look at the next page there, that's illustrated there. We have t1 v1, t2 v2, so we're really figuring out the slope of a vt graph, and the slope of that gives us acceleration, average acceleration. Instantaneous acceleration can also be determined using a velocity time graph that is parabolic by determining the slope of the line tangent at that specific moment. So you may want to highlight this part right here, very similar to what we did before. So for example, if we were looking at the instantaneous acceleration at 7 seconds, that's right here at that point. So what you have to do is make a tangent line there, kind of maximizing what the slope would look like. So I did that here on this booklet, and then picked 2 points in there. 5, 2 is a point that went through there, and 10, 18, and basically just figuring out the slope of that tangent line. And in this case, works out to be plus 3.2 meters per second. So as shown in the previous example, instantaneous acceleration could be determined using the VT graph and calculating the slope of the tangent line at that specific moment. Okay, the next sheet you have is this. So we did that matching sheet earlier on. This kind of looks at the same thing, except going a few steps further, looking at PT graphs and VT graphs. And then on the next side, we're looking at PT, VT, and AT graphs for a specific motion. So maybe I'll get you to pause the video right now and see if you can figure out just this first part A for now. See if you can match up the graph with the specific descriptions. Okay, if you had a chance to do that, so a car, now again, PT graphs, again, slope is velocity on a position time graph. So wherever you see the word velocity, that means slope. So if you look here, a car with a large positive velocity comes to rest. So in other words, a graph that has a large positive slope comes to rest. Large positive slope right here, eventually reaching a slope of 0. So that is in fact the graph. Graph C is the answer there. Again, think of velocity as slope. 2, a car at rest initially, so going 0, gains a positive velocity or gains a positive slope. So not moving, then gains a positive slope. That would be this graph here. Initially the slope here is 0. Slope is bigger, bigger, even bigger yet. So graph B would be the answer for that one. 3, a car with initial positive velocity maintains it. So initial positive slope maintains it. Let's graph this graph right here. So graph A, positive velocity, positive slope. 4, a car with initial negative velocity maintains it. So right here, a negative slope, negative velocity, and it stays at that point. So graph E. 5, a car initially at rest gains velocity negatively. So a car initially going 0 gains a negative slope. So initially not moving, the slope here would be 0, but you can see the slope gets negative, more negative, really negative, so we're talking about F in that case. And then lastly here, a car with a large negative velocity comes to rest. So in other words, a large negative slope eventually approaches zero slope. Large negative slope approaches zero slope. So as we can see, that one must be choice D there. Okay. And so now with that, looking at what the VT graph would be for each of these graphs. Okay. So if I am looking at graph A here, drawing a velocity time graph. So once again, slope gives velocity. So the slope of this line gives me a constant positive number. So a constant positive number, a constant positive graph, that would be graph 2 right there. So position graph A matches with the velocity time graph 2. Graph B, so if you look at a couple of different points here, slope is 0 right there. Tangent line here would mean slope is that, and then slope is that. My tangent line isn't very good. So initially 0 velocity, small positive, large positive. So of course that is going to look like this one here. Initially 0 velocity, 0 slope, 0 velocity, small positive slope, small positive velocity, large positive slope, large positive velocity there. So that's a tricky one. That one deals with VT graph 2. If I look at C here, looking at tangent lines, so the slope right here is a really large positive, kind of a medium positive, and then 0. So 0, a large positive slope, which is a large positive velocity, medium slope, medium velocity, 0. So large positive, medium, then 0. Large positive, medium velocity, then lastly 0. So that has to be 3. Graph 3 matches that one. Looking at this one, so here the slope here is a large negative, medium negative, 0. So looking for a graph that has a large negative velocity, medium negative velocity, and 0. So let's see here, large negative. So this here is in the positive region, 0. This is in the negative region down here. So positive velocity, 0, and this is in the negative region here. So if I look at this graph, a large negative velocity. After this time here, it's a smaller negative, and then of course over here it's 0. So that corresponds to graph 6. Okay, almost done here. You can see we have 2 extra graphs in the velocity section here. So here we have, okay, the slope is just the same everywhere, and that slope is going to be a negative value. So looking for a VT graph that's a constant negative value, of course that's right here. Graph number 7 has a constant negative value. And then lastly here we have this one. So starting off with 0 velocity, 0 slope, kind of a medium negative slope or negative velocity, then a really large negative slope corresponding to a really large negative velocity. So 0, negative, negative. 0, small negative velocity, really negative velocity. So that corresponds to graph number 8. So there we have it. If you need to watch the video again, please do so, because it's really crucial that you nail this part down, because on the next assignment we look at PT, VT, and AT graphs. Okay, so we'll see you soon for part 2.